open window or zoom into this portion of the map. And as we get to the point where we want to use to place the new item, then we can go to our menu here and then just select place or hit new node, and again a form would come up for you to enter the information for that new node. Every node has a unique ID number. Let's say this node here is called CL100, and then the node is defined also by its cover elevation. Let's go ahead and just type in cover elevation here, and as we type the cover elevation, you'll see that the terrain elevation is also updated using the same numbers. In cases where you know that the manhole was either buried or raised, you could go ahead and change that terrain elevation to what it's supposed to be. And then you can go ahead and type in the bottom elevation for that node. Let's say if the manhole was 6 feet deep, you could go ahead and here just type in the bottom elevation of, let's say, 542. And then every node is also defined by its dimension, which is the diameter of that rim. The node is also defined by its system. Here we have 4 different systems. You can use common water, drain water, or other rainwater, wastewater. And in this case here we're putting a node for wastewater, so let's just go ahead and select wastewater. Also, we have different types of node. A node could be a manhole, it could have been a grading or catch basins, a node could be an outlet, a lift station or whatnot. So let's go ahead and select the node that we want, manhole. And again here we have to remind you that the client can really tell us or would or should tell us exactly what they want to go in this drop down list, and each one of them can be changed to reflect exactly the information that the client wants to put onto the application. So you can go ahead here and select exactly the information that corresponds to this new node, and as you do so and get all the information, then you can go ahead and hit enter data. And when you hit enter data, then you are somewhat given a block or cell which represent the node that you're placing, and then go to exactly where the node is located and hit the data point, and then that node is placed as a manhole or whatever node you selected in that specific location. You can go ahead here and select a different one or place a new one here. Let's say call it CL102. Say the cover elevation, all of that is the same, but we want to choose a different system. This time we are placing a storm or rainwater node, and again it's a manhole. We can leave it to a manhole and then go back here and hit enter data, and again you are given another block or another cell to place exactly where that manhole is located. Go ahead and hit the data point, and then that cell is also placed. The node comes back for you to enter more item if you so desire. If not, just go ahead and close the form. As you can see here, you have 2 different circles. One is red and the other one is blue. The red represents the wastewater system, and then the blue would represent the storm or rain water system. And as you can go in and zoom in with those nodes, you would see that each node is somewhat annotated with the information that you type in those forms, which goes also into the database for that specific node. We can zoom out and zoom into the other one also, so you can see exactly the different system. In one, the system was S corresponding to wastewater or sewer, and this one here, the system is called R corresponding to rain or storm. But as you know, in this era of GPS, most people would probably want to go out and select the manholes and put all of that into a file or database and have you import it at once. And here the system would allow you also to do the same thing. You could go into again the menu and select import nodes. This time you have a form which allows you to select which kind of node you want to import. This could have been catch basins, sewer manhole, storm manhole. Let's go ahead and select import sewer manhole and just hit the import data. And then as you can see, the system would go into our database and find in one table all the information that needed to be imported and import that information onto your map. Here we have only 5 items imported, but it could have been a situation where you can probably go in and survey your entire city and have basically the application import all those nodes for you. And as we could go back and look at the database, you can see as we go to the database, look at the nodes and where they are, the nodes that are imported. Let's go back and click on this. You can see here the node that we imported. They come from this table here, SMH, and on this table we only have 5 items, and these are the 5 items that are imported onto our map. and this could have been again, as I said, 100, 200, 2000 items, and the system would have still imported all those elements into your map, and then go ahead and annotate them to show exactly what they represent. As we can go here and using the edit element, we can edit the element and tag one of those node, accept it, and you can see exactly the information that's going to your database. That node is man 100, and you see its cover elevation, its bottom elevation, and the system and the type of node that it corresponds to. At the same time, you would be in a situation where you have to place all those nodes at one time. You could also be in a situation where you want to delete all of them or part of them. The application again allow you to go back and select which one of the node that were imported that you wanted to delete, and you can go and here select sewer manhole and hit the delete data point. It will go back to that table that we just shown and read whatever information is left on that table, and that's what you want to delete, and it will delete that exactly from your map. And as you can see here, everything is deleted from your map, and at the same time everything is deleted also from the database. Now that we've placed the nodes that define the beginning and ending of a pipe, let's use the program to connect them. As you select new pipe, you are presented again with a form to fill in. A pipe is defined by its upstream manhole and downstream manhole or node. And as you go in and select the one that you want, like from manhole here, we can go ahead and just type in CL. So to go to CL 100, go to the next one, which is a downstream manhole, and again type in CL, gives you 100, and let's go select CL 102. And as you can see here, when we put the upstream and downstream manhole, the ID is generated using those two, and at the same time the program goes in and calculate the length of that pipe, because it knows exactly where those manholes CL 100 and CL 102 are located. And once you do that, then you can go in and fit the rest of your information. As we can see here, you see the deltas. The deltas are somewhat the differences between the cover or rim elevation of the manhole and where the pipe is either leaving the manhole or landing onto the manhole. So your invert elevation, the delta would allow you to calculate then the invert elevation. We could go ahead and let's say here the delta from one is 2, and then the delta from the other one, let's say, is 3.5. And again, as we enter those delta, then the program would go and calculate the invert elevation for that pipe. You can see now the from elevation calculated, the to elevation also calculated. At the same time, the program would go in and calculate the slope of the pipe, because it knows now the length and it knows the invert out and the invert in of that specific pipe. Just like for the nodes, again, if each pipe belongs to a system, and you can see the different system here, we can go ahead and select the system we want. In this case, wastewater, and then the pipe also has a specific material, and then the list can be something that you can add to or retract from, and we can go and select the material that we want, and then also go in and select the dimension of the pipe that we are placing. And you see a lot of other drop down lists here. We'll move down to the one that has the type, which allows us to select whether our pipe is a gravity type pipe, pressure, or whatnot. We can go ahead and select gravity, and again, just like for the nodes, you can go ahead and enter or select the information that best describe this pipe, and then hit the enter data. And as you hit the enter data, you would see the form would come back up for you to select a different pipe. But if you go back and look onto your map, you'll see that the pipe is already drawn and showing the direction of flow also of that pipe, and we can collapse that form. And as you go in and window or zoom in to the text, you will see again that the pipe is annotated using the information that is entered into your database, putting the dimension, the slope, the length and the slope of that specific pipe. And just like we shown on the edit information, you could go back and hit the edit element and tag on that pipe, accept it, to make sure that it shows the information that you've directly entered into that form. And as you can see here, that's exactly the same pipe that we just entered onto into the database and placed in our map. After pipes are placed, you would need to connect them with the laterals that goes into somebody's houses or properties. Again, as you go to the menu and select a new lateral, a form is again presented to you to enter the information for that new lateral. If you have a service number, you could go ahead and place it in. If you don't have, you can just leave it either NA or blank, but the service number would always help you to connect to some other database or information, and retract or get information from those tables and put it into your new database. So let's go ahead here, select that the material also is, let's say, clay, and go ahead and type in the distance, and the distance is usually taken from the downstream manhole, and let's say that our new lateral is going to be 100 feet from the downstream manhole. It's going to be going north. We could go here and put in a length for the lateral. Let's say it's 25 feet. Let's go and enter the depth of the property line, let's say 4 feet, and then the dimension of the lateral, again we can go and say, let's say it's a 6-inch pipe. And then again, if you know who made it, you can go in and type in the manufacturer of that lateral also. And again, as you go and hit enter data, you are asked to select the pipe. You don't have to select the pipe exactly where the lateral is located. Just select the pipe anywhere, hit OK, and then as you can see, the program would go in and place the lateral exactly 100 feet from the manhole going to that house that is supposed to serve. Let's go ahead here and place a few more. Let's say we place another one at 200, again going north, the length 25 feet. Again, hit enter data, tag the pipe, accept it, and again you can see the lateral placed exactly again at 200 feet from the downstream manhole and going to that house. We can go and place a few more. Let's say we have another one that's located to 500 feet from the downstream manhole, again 25 feet length, and then the property also depth at the property line 4 feet, and the dimension 6 inches. Go ahead, hit enter, tag the pipe, accept it, and again you'll see that it'll place again a different lateral or new lateral at about 500 feet from that downstream manhole going to that house. Let's say this time we have one that's going 600 feet, but going south this time from the pipe, and then let's go ahead and accept it and hit enter, tag again the pipe, accept it, and this time you will see your line going south again 600 feet from the downstream manhole and going to a parcel that would be located in this area here. Let's say we just go ahead and making a mistake and typing that we have a lateral that's located, let's say 950 feet from the downstream manhole and going south or going north. Hit enter, go back and tag the pipe, hit accept. Here the program would know that our pipe is not long enough to take a lateral that would be located 900 or so feet from the downstream manhole. So it will ask us if we want to delete the lateral record or if we wish to go and select a different pipe, and in this case we want to delete, so we'll just go ahead and hit yes, and then it will delete that record that was already inserted into the database, and again bring a form which would allow us to go back and place or change the distances on that lateral and place a new one. So we could go ahead and let's say this time we just have 600, another lateral, or 650 maybe, and then our lateral is going north, and go back, hit enter data, and then tag that pipe, accept, and then as you can see, unfortunately problems do happen. They need to be documented and fixed to create a healthy environment for the resident. As you go and select new observation, again a form is shown to you to enter the type of problem that you have and where it's going to be located on your pipe. Let's say that we have some hard deposit in our pipe. Go and select that, and then the problem is still active, and here you are given a number of classes that would define the urgency of maybe fixing your problem, going from 0 to 4. Let's say this is something that needs to be fixed right away and has a class of 3, and then again go in and tap in the length of that problem in the pipe. Let's say it's about 10 feet within the pipe, and if you have any remarks, you can go ahead and again type in the remark to describe or better describe that problem that you're just entering, and go ahead and hit enter data, then go to the pipe where the problem is located or where it was found, and just tag the pipe in that location, hit accept, and as you would see here, a line or yellow line would be placed on that pipe exactly where you type it, having a length of 10 feet to show that you've already somewhat put information onto your map showing that you have a problem at that specific location. Let's go ahead and place another one. Let's say this time we have some infiltration into our pipe. Again, we can go ahead and change the class to what we want. Let's say here the class is 2, and for the length let's put 0 because it's just at a certain point of that pipe, and again go ahead and hit enter data and tag the pipe where the infiltration was found, and then accept it. And again, as you would see here, your pipe would be somewhat shown with a yellow line or yellow dot that show that you have a problem exactly at that specific location of the pipe. And again, every time you do go place a new one, the form would come back, allowing you to place more until you don't feel the need to place any more problem again, and then you can go ahead and just close that form. And mistakes do happen, and they need to be corrected while maintaining database and graphic integrity. Let's assume that the second node that we placed was not of the right system. We can go ahead and select here change node ID, and go back and tag that node and accept it. And as you can see here, a form comes up which allows us to change the system of the node and even its number, the ID number itself. Let's say that we chose rainwater, but this node is really again wastewater. Let's go and change that to wastewater. And again, let's just go ahead and say, since it's wastewater and we have a different numbering system, we want to change maybe the number of that wastewater to CL103 and not to leave it to CL102, and go ahead and hit OK. And as you would see here, your node that was blue now becomes red, which means that it has changed from storm or rain to wastewater. And as you can see, the system that was R before now is S, which corresponds to a wastewater, and the ID number of that node that was CL102 is now changed to CL103. And again, not only that node is changed, but everything else that is linked to that node is also changed. As you would see here, that your pipe that was before CL100, CL102 is now CL100, CL103. The dimensions stay the same, the length and slope also stay the same, but all the information related to the node for anything that is located onto the pipe or pipes that are connected to that node would also have been changed, because we have changed the node ID number. Let's say this time that we've made mistakes on the engineering data of that node, and we can go in here and this time select change node elevation. And again, let's go ahead and tag that node and accept it. And as you can see here, again, another form comes up which shows the node number, the type of node we have, the dimension, and then showing the cover elevation, bottom elevation, and so on for that node. Let's say that our cover elevation really is not 548, but it's 546. And our bottom elevation here is 540. The terrain elevation still being the same, which means that our node has been buried under some street or something like that. And then we can go ahead and hit the update button. And then again, as you would go and zoom in and look at your information, you would see that your information has been updated to reflect the new data that you just entered onto that node. And again, all the pipes and all the laterals to those pipe and observation would also have been changed to reflect that information. For each pipe that is connected to the node, the deltas would change to maintain the slope that we have, because we assume that the invert elevations are still the same on that node. It was just either raised or buried again. And again, as we go in and change node information, we could have been in a situation where again the pipe inverts needed change, and we can go into our menu again and just go ahead and select change pipe invert, and then tag the pipe, accept it. And just like for the nodes, again, we are shown here the dimension. We could change the dimension to something else, and at the same time we also see the invert elevation of that pipe. Now we have elevation going here from 546 to 544. Let's say if you wanted to say that this elevation is really going from 546 to 542 onto that pipe, and go ahead and hit update again. And as you would see, and going back to your system, you'll see that your slope now has changed from what it was before to a new slope that reflect the new elevation that we have put into that pipe. We could also be in a situation where maybe data is placed but not at the right location, and let's say the node that we just placed here was not really at the right location, and we need to move it to a different location because that's where it's supposed to be located. So we can go in here and tag that node, and then go to the location where we want to place that node. Let's say that node is maybe on this side of the street, and accept that. And as you can see, as we move the node, the pipe is also redrawn to connect to the new placement of the node. And not only that, you would also see that all laterals and all the problems that we have found before are also redrawn to show exactly where they should be located, giving that new placement of that node. And again, as you go back here, you would see that not only your map and graphic data is updated, but also everything in the database that is linked or related to that node is also updated, and that slope of that pipe now has changed from what it was before to the new slope. And as you can see, also the length of the pipe has changed also from its original value to the new value, which correspond to the new location of that node. Let's say a certain node is of interest to you and that you wanted to find where it's located. You can again go into the menu and just go and hit find node. Either you can go to the list and select the node you want, or you can just go in and type in, let's say 5C, that's the node you want to find, and then go in and hit the find node button, and as you would see, the program would just go into the map and zoom into exactly where that node 5C is located and then highlight it for you. And if you had information on that node, now you can go in and start probably processing that information. Let's say that we are in a situation where we had some pictures or detailed drawing that we wanted to show for that node. We could go back again to the program and just say, let's say show node picture, because we have a picture maybe of that node, and then go in and click that node, accept it, and then as you can see, the program would go in and find the picture of that node and bring it into a different window. And in this case, if you had people maybe outside, looking for information, and they didn't know exactly, which one to choose, then you can direct them from this picture and tell them exactly that the node you want them to maybe fix or study or whatnot is located at a certain, place on the street, or from a house corner, power pole, or whatnot, and so on. It could also be a situation where maybe you want to do some drawings that you want to add to a report or whatnot. Again, the program would allow you to go in and, let's say, and place or create a diagram for the node. Let's say we want to go and create a diagram for this node. Go ahead and click it, and then accept the node, and then you ask to move to a location where you want to place that node. We can go in and zoom out of this drawing a little bit, and then to a place where we want to maybe put that drawing, hit reset, and then hit the data point. And then as you can see here, the program would go and create a drawing of your node showing the different pipes and their direction that are coming to that specific manhole. In this case here, you can see we have an 8-inch pipe coming from 5B, we have a 8-inch from 11A, and then we have a 10-inch going to node 5D. And then again, you'll see a form that shows the manhole number, the dimension of the manhole, maybe the date, and then some text showing maybe the city or whatnot. And all of this can be designed to reflect on what the clients really want to show or want to do. And at the same time, you go in and create a diagram for that node, which is a plan view basically of that manhole showing the different pipes coming in. You could also be in a situation where you want to go and create what could be a profile of that node, and just go on the menu and select node side view, and then go in and click that node, and then again accept it, and then you ask again to move to a location where you want to place that new drawing. Let's go here, down here, and just hit OK. And as you can see again here, we created a drawing that this time shows again the ID, the dimension of the node, the cover elevation, the bottom elevation, again as I said, the date or some other information that you want to show. And then as you go in and zoom into, again you will see showing somewhat where the pipes are landing in and where the pipes are coming out of the manhole and going to a different manhole. And here again you would see that we have an 8-inch pipe from 11A, and it gives the invert elevation of that pipe. We have a again 8-inch pipe coming from 5B, again given the invert elevation, and then we have a 10-inch pipe going to 5D, and again showing the invert elevation. And this can also be designed in a way that it would show the logo, or some type of sheet that the company or the city wants to use. And your office should keep track of the people assigned to them and the material and or cost associated with solving them. When you go to your menu again and select add work order, again you ask here to select any one of the observation that you already placed on your pipe to create a work order for that. Let's go ahead and select this one here and accept it. And as you can see, the program would go in and create a screen capture of that section of the map showing exactly where the problem is located, and putting a circle around that problem, and then give us a form that we can fill in to exactly show what the problem is and then who's assigned to do the work. Here we could have add some description to that problem, or we could just leave it as the title here is shown. And then let's say we have two people here working on this. Let's say John and Trey are working on this problem, and then we can go ahead and put a date that the problem is scheduled. Let's say this is scheduled to be done on July 14/03, and it hasn't been fixed yet. It's only in progress. We can put that, and if we have remarks or whatnot, we could go ahead and put that text into it. We can go, and if you wanted to, hit print and send this to a printer, and it will print exactly the form and the map at the same time. Or we could go ahead and just hit save and have this item saved into our database so that we can later on edit it and add new information onto it. Let's go and hit accept and then close the form. And as I said, we can go ahead here, because that you send people to do work. When they come back, you would want to have a way of somewhat updating on what they have done and making sure that your system keep track of what everybody is doing and how much it's costing your city or your company. So we can go ahead and here hit edit work order, and again tag that work order again, or that observation, and then accept. And as you can see, it brings the same map, and then bring the form again that shows that we've assigned this problem to John and Troy, and it was supposed to start on the 14th, and it's still in progress. If this problem has been fixed, then we could go ahead and say okay, it's fixed, and type in the date it was fixed. Let's say that it was fixed the same date, so we go back and type in again 07/14/03, and here we can go ahead and change the status from in progress to completed. And then in the remarks, if we knew that this costs us some money, we could go ahead and type in the cost. Let's say this costs $235 to fix, and then again we can go and print this form if we wanted to, or we can go ahead and just hit the update and have then the application update our database to show that we have put in the right information onto that form. And as we go and close this, you can see that the form that was a yellow line on your pipe now has become a gray or dim line on your pipe to show that this has been fixed and it's no longer a problem for us. And as we do have those problems, we could go into the program and see sometimes how many problems we have fixed on a specific pipe or whatnot. And we can go and say choose view pipe work orders, and then click that, and then go in and type in tag a pipe, accept it, and as you can see, the program will bring in a microstation text window here that shows the pipe that we've selected. Let's say S6 and so on. And we could go back here and see the ID of the pipe, the material, PVC, the length of the pipe that we selected. It will show the system, the dimension, the slope of the pipe, and we can see all the problems that we have on that pipe. There was a problem here that was just an obstacle in class of 3 for 20 feet on that pipe, and we had assigned for that problem John Mark. It cost about 125. It was done on May 18, and I mean it was scheduled May 18, completed May 19. You would see that there was another problem here that was infiltration again, that the class 2 again 0 feet. It's just at one point, and we had John and Bob doing that job, and it says when it was scheduled, completed, and then you see the cost. And again, you can see the last problem that we put in was a loose deposit into that pipe, class of 1, and then the length of it. And again, as you can see, we've assigned John and Troy to do to fix that problem. The status now is completed on the 14th, and it costs us $235. The same way you can show this information and put it onto a microstation text window. This could have been information that you sent to a Word file or an Access database table or a spreadsheet or whatnot. At the same time, you could have just decided that you want that information onto your map, so you can print the map and send it to somebody else. Then you can go to the menu and select again, this time annotate pipe with work order, and then let's just change this here to make sure that it's going to be, and accept that pipe here. And as you can see, you see some text again that you can go in and place onto your map to show under that pipe what you have done, or what the work has been completed for that pipe itself. We can reset here and close this, and then as you can see the text here, if you want you can zoom in to the text and see that it's almost the same information that you saw on that microstation text window, again showing information on that specific pipe and giving the different problems on the pipe. The first one, obstacle 320 feet, and then the cost, who did it, when it started, when it was completed. And then again you can zoom out or scroll down and see exactly that you have another problem here that was infiltration, and then another problem that was just the deposit loose, and so on. And this information can stay on your map in a way that when you print the map, somebody can look at the map and see that on that specific pipe all this kind of situation had happened, and that they were fixed or they're still in progress as being taken care of. The application also allows you to list all the pipes that you have in your program. Actually, you can just go again into the menu and select scan pipes. A form comes in with a button that you can just click on, and then it'll go in and scan your map and find exactly all the pipes that you have in your map and give you a list of those pipes showing the ID, that's the MS link that would describe the record that in the database that correspond to that pipe. Got the dimension of the pipe, the length, its slope, and some other microstation data like element ID and file position. And as you can see, this would allow you to somewhat do a little bit of quality control, looking just at the slope and seeing maybe some of your pipes that don't have the right slope, that you could go in and find where they are and maybe change it if you want to. And here, if you wanted to see a pipe, you can just go to the program and click on it, and as you can see, the map would zoom into that pipe again and highlight it and bring a form that shows the detailed data on that pipe. This is just an informational type form, but we could have changed it in a way that you could go into that form and change like the invert elevation onto those pipe to recalculate the slope and show exactly what it should be. If you want, you could go back to the list again and just select a different one if you wanted to, and have the program again just move into the system and find exactly where that pipe is located. Here you can see that we had a pressure pipe that's going from that lift station to some other locations. So not only the list would allow you to see exactly all the information that you have in your system, but you can also take the list as being a means of just navigating in your map and finding exactly where informations are located. Here we go ahead and just select another pipe, and as you can see, it'll take us where we were before and show exactly a different pipe and highlight that and so on. And we can go ahead and just let's say that this pipe was already drawn, but we found out later on that we missed a manhole and that we want to go ahead and place that one onto the pipe. We don't want to have to delete the pipe and everything else that's on it and restart from zero. So here we want to use the program and either split the pipe or insert a new node, and go ahead and select insert new node, and then a form is again shown for you to type in the information that would correspond to that new node. Let's go ahead and select or type in the name of that node, let's say CL200. Again, here we can go ahead and put the information if we want to, let's say 543 to, and then let's say to, or let's go back to here and say the cover elevation is 546 if we want to, and then let's say the bottom elevation here is 540 if we want to again, and the rest is the same. It's again wastewater, manhole, and then we can go here and hit enter data and go to the pipe and select where we found that manhole or where we want to split the existing pipe into two different pipes. So let's go ahead and let's say it's in front of this house, tag to that pipe and then accept it, and as you would see here, the program would go and split the pipe into two sections. And as you go ahead and look at the information on the sections, you would see here that this pipe has been renamed CL100, CL200, and the length of the pipe is recalculated, the slope of the pipe is also recalculated, and then here you can see exactly the same thing going on the other section. But in this case, you would have to go back to your program and select change pipe inverts, and then you can go in and tag one section of the pipe at a time and change that invert. Say here we've gone from 546 to 544. If this is the way we want to leave it, then we can leave it that way. Let's just say that it was going from 546 to 543 on that pipe, and then go ahead and hit update. Again, as you go to your map and zoom in and look at the information, you would see that your slope has been changed for that pipe. due to the new invert elevation that you put in. And you could do the same thing also for the other pipe. Go ahead and again, go to change pipe invert if you want, and then tag that pipe, accept it, and then this time you can say let's say your pipe is now leaving from 542 and it's landing on let's say 540 on the other pipe, and again hit update. And as you go to your map and look at your slope again, you would see that your slope has changed to reflect the new pipe inverts and so on. And the same time you go in and can place things that you've missed. You can also use your program to do some deleting. Like you could place a node and find out later on that really there's no node in that specific location and you need to delete that. Then you could go in and select delete and delete node, and as you go in and select the node and accept it, it'll delete not only the node, but it will also delete from the map everything that was connected to the node, and it'll also delete anything from the database that has reference to either the node, the pipes, or lateral observation, and so on. And you could go ahead and do the same thing for the pipe if you want to. If you go ahead and select delete this time and go ahead and delete a pipe, you would go ahead and select the pipe that you want to delete, accept that, and again as you can see here, the pipe is deleted, and then all the laterals and observation that were connected to that pipe are also deleted. And again, just to clean this map, we'll go ahead and delete the rest of the nodes that we placed onto the map, tag that node, delete it, and again tag this one, delete it. So you have especially taken out everything from the graphics, and at the same time deleted everything from the database, and not have to do it a two-step process where you would have to go to the map, delete something, and then go back to the database and delete the same thing. So as you can see here, we have just tried to show you a concept, and what we want you to remember is that this is not a software, it's an application. And as an application, it's going to be up to you, the client, to decide onto what you want. You're going to be on the driver's seat. So this is going to be your application, and for that reason, it would be for you to define exactly what the initial process is going to be like, and it also would be for you to design exactly what the final outcome should be. Our job is to somewhat bridge those two for you, to make sure that that gap is closed so that you can go from your initial process to your final outcome, making your work a lot easier, and making your work also more effective and more efficient for you and your company. We thank you for your attention.